Hello and welcome to Verisurf software. In this video, we'll see how to reverse engineer a part from scan data using Verisurf's reverse module. There isn't a single right way to reverse engineer a part, so we'll use a variety of methods and see what tools are available. For this demo, we'll start with a scan of the part, which we'll import from an STL file. Let's fit the view. We'll then save to the MCAM format. We'll begin by moving the system axes to the front corner, so we'll first create planes for the alignment. Let's open Edit Mesh, select the top and front regions, and fit planes through both. Next, we'll align the mesh using Feature Align. Let's fit the view. The planes control the orientation, and the sides of the mesh locate the origin. We can view the alignment using the top, front, and right views. The alignment looks good. Let's choose OK and fit the view. We'll continue by using Slice Mesh to create wireframe for the solid. Let's choose Along Z, rotate the mesh, and drag the slice plane just above the bottom edge. We'll then choose Slice to create a group of clouds. Let's fit the view. These give us a template to sketch the wireframe. Next, we'll use Wireframe, Rectangle to create an outline of the part, starting at the origin. Let's zoom in for a better view. We can round off the values or adjust them to the outline. We'll then use Fillet Chains to fillet all four corners at once. Let's use a 3mm radius. We'll fit to see the result. Let's choose 2D mode. Slice 4 is a short slot. Let's zoom in for a better view. We'll choose Rectangular Shapes, Obround, Center. We'll then sketch a slot, rotate, and adjust the dimensions. Let's round them off. Let's fit the view. For Slice 2, we'll use Edit Cloud to fit the round part of the cloud to a circle. We'll then fit a line across the top. Finally, we'll export the features to CAD and hide them. To finish the outline, we'll sketch a line from the center through the top. We'll then offset the line to both sides and clear colors. Next, we'll fillet the corners. Let's use Divide to clean up the outline. Finally, we'll fillet the arc to the sides. Let's fit the view. Slice 3 is another obround. For this one, we'll right-click and fit to a slot. We'll then export the measured slot to CAD and hide it. We're done with the clouds, so we'll delete them. Next, we'll create wireframe for the pockets. Let's choose 3D mode and choose Slice Mesh. We'll then move the slice plane just above the fillet. This captures the outline of all 3 open pockets. Let's choose Slice and close. The plane on top of the pocket has a z-value near 12.75. Let's set z-depth to 12.75 and C-plane to 2D mode so we can sketch in that plane. Next, we'll sketch the main pocket. Let's zoom in for a better view. We'll extend the lines beyond the rectangle. We'll then connect them. Let's fillet the inside corner. Adjusting to the cross section. 45 looks good. For the top left pocket, we'll sketch one side, round off, then draw a vertical line from the center. We'll use this line as an axis to mirror the first. Clear colors and connect the lines. Let's delete the axis. We'll then fillet the lower vertex. About 6.1 or 6.2. For the final pocket at this Z height, we'll sketch the lower line, round it off, draw a horizontal line to its end point, and connect them. Finally, we'll fillet the lines and adjust. 7 looks right. We're done with these clouds. Let's delete them. We need to draw a pocket for the slot at a different height. We'll use Edit Mesh to fit a plane to the shoulder, and then fit a slot to the wall. The slot projects to the XY plane by default. Let's modify the fit to project to the shoulder plane. Finally, we'll export the slot to CAD. Let's create a surface to trim the solid. We'll choose Edit Mesh, select the top contour, and copy it to a new mesh. We'll then choose Power Surface. The results group shows the maximum error as we adjust the values. Let's extend the edge for trimming and save. We're finally ready to create the solid. Let's choose Solid, Extrude, chain the outline, and adjust the height until it just covers the surface, nothing too precise. On the Advanced tab, we'll set a 1-degree draft angle and create the solid. We'll then use the surface to trim the solid. We'll choose the side to keep and the surface. We're done with the surface. Let's hide it. Next, we'll create the pockets. Let's choose Extrude, chain the 3 outer pockets. We can unshade to see the wireframe. And set Type to Cut Body. In a new operation, we'll cut the pocket for the slot. In a final operation, we'll remove the wireframe in the XY plane. Let's check our work. We'll continue by adding the cones and spheres. Let's use Edit Mesh and fit a plane to the shoulder of the first cone, and then fit the cone. Let's repeat for the other cones. Plane first, then the cone. This approach automatically creates an intersection between the plane and the cone. Let's also fit one sphere. They're all the same. Its radius is very close to 10 millimeters. We'll take note of that value and undo. Before exporting the cones, we'll use set values to make them parallel to the z-axis. We'll then export them to CAD and hide them and the mesh. We need only the top circles where the cones intersect the planes, so we'll delete the rest of the geometry. We can now extrude them as solids. We'll chain the first, choose Add Boss, and set the distance to the pocket. We'll then add 15 degrees of draft and reverse it. Let's choose a new operation and repeat for the other two using 1 degree of draft. We'll add the spheres as simple solids. Let's choose 3D mode, and then choose Sphere. We'll select the center of one circle, set the radius to 10, and lock it. We'll create the other spheres just by selecting the circle centers. We're done with the wireframe. Let's hide it. We'll combine the spheres with the main body. Let's choose Boolean. Select the solid as the target body and the spheres as the tool bodies. We now have a single solid. We'll finish it by filleting the edges. Let's choose Constant Fillet and choose the pocket, the contour, and the shoulders of the cones. We'll then set Selection to Edge and select the front edges and one of the bottom edges of the small pocket. Let's repeat for the other one. We'll then choose OK and set the fillet radius to 1.25. Let's review the model. We'll perform one final step and create a shell of the solid so we can 3D print it. We'll choose Shell, select the face we want to keep open, and set the thickness. Let's have one final look at the completed model. The result of our work is a parasolid, which we can export to a variety of file formats. That's it for the demo. I hope you enjoyed it, and thanks for watching.